Here's an example for our introduction to ellipses. We haven't got all the interesting things about ellipses yet, but we just got to the point where we started figuring out that an equation with x squared and y squared but with unequal coefficients is going to give us an ellipse. So here's an example that you might find in a book. I didn't get out of the book for once. 12x squared plus 27y squared equals 108. Find the vertices, the lengths of major and minor axes, and sketch the graph. And the main thing you have to do, it's really pretty easy, you just have to match the pattern, which is the standard form, in other words, the standard form for an ellipse. And this is what we were getting towards at the end of class. If you have an equation like this, suppose it was, you had an equation like this. X squared over a squared plus y squared over a squared equals 1. That would just be kind of a silly way to write x squared plus y squared equals a squared. And that's a circle. But what if we took that and we changed it so that those coefficients weren't equal? What if that were b? Then that's something where we've stretched, instead of taking the unit circle and stretching it equal amounts in both directions, we've stretched it unequal amounts as long as a is not equal to b. And that's an ellipse. A circle stretched in unequal amounts in both directions. And so let's go ahead and match to that form and then see what that tells us. Okay. Actually, let's see a little bit more about what this tells us. When you're in that standard form, the main thing you can do is you can find the intercepts. Okay. Well, one thing I should say first of all is that we haven't we haven't shifted, we haven't translated this circle at all. We've just stretched it. So, yeah, don't show this message again. Thank you. First, really important fact is that the center is still the origin. And it's still symmetric about the x and y axes. One way you can tell that from any function or any equation is that x and y only appear as x squared and y squared. If you put in x or minus x, doesn't matter. Y or minus y, doesn't matter. That's what's going to give us the symmetry about the axes. And what I want to do is I want to connect it to this picture by finding the intercepts here. If x equals 0, x equals 0, then I just end up covering up part of this equation. I get y squared equals b squared. Because I just cover this up and then I can push the b squared over. Okay, so that's going to mean that y is plus or minus b. Remember the plus or minus, that's pretty crucial. Oh, where's plus or minus? There it is, plus or minus b. I'll get the picture back in a second. And if y equals 0, that's going to be the x-intercepts. That's going to tell me x squared equals a squared. Because I can just cover up this part, it's gone, and then x squared over a squared equals 1, or x squared equals a squared. And that's going to lead to x equals plus or minus a. Okay. So that means that it's going to have these four intercepts, plus or minus a on the x-axis, plus or minus b on the y-axis, and it's going to look like something like a stretched circle going through those 4 points. That's basically all you need to plot an ellipse. We'll deal with these 2 points, which are called the foci and c, next time. I'm going to skip that for now. So that's a very general thing, is that these numbers give you the intercepts. And so we can do that for our example. But wait a minute. Let's go back to this example. Let's copy it down here. We got a problem. That's not in the standard form yet. And the important thing is that it's really, really, really important that for the standard form that this be the number 1. It sort of feels weird that that's important, but that's the only way that this calculation would have worked. If this had not been a 1, like y squared over b squared equals 10, that wouldn't lead to y equals exactly plus or minus b. So it's important that this be a 1. So I need to divide everything by 108. Well, 12 over 108 turns out to be 9. And 27 over 108 turns out to be 4. 1/4 rather. So 12 over 1 over 8 is 1/9. And 27 over 1 over 8 is 1/4. And so it's conveniently in exactly the right form. I'm just going to do one more thing to it. I'm going to write that as a square. Now I'm making this really easy to start with, so that these did happen to be perfect squares of integers. In general, that's not going to be true, but let's start out with a fairly easy example. Okay, so this is going to have intercepts at plus or minus 3. Still need that plus or minus. There it is. Plus or minus 3 comma 0 and 0 plus or minus 2 are the intercepts. Okay, so in this picture, this would be 3. Let's see, I have a text box open. All right. Hello. I thought I had a text box open. That would be 3. This would be minus 3. This would be 2. And this would be minus 2. Okay. Kick that. Okay. And so there's enough for a sketch. We just plot those 4 points and trace something that looks vaguely like a stretch circle. We don't have to worry about anything in between necessarily. If we wanted a really more precise sketch, there's a couple of other points that aren't too hard to plot, but they're not super important. Okay, and oh yeah, and then one more piece of terminology. The major axis is just the longer of the two axes. Longer axis, and it's the long sort of diameter. And it's just equal to 2a. And so that's just equal to 6. And the minor axis, that's the smaller axis, shorter, I guess I should say. That's really the opposite of longer. Shorter axis, so the short diameter, if you will. And it's that's going to be equal to 2b always, and that's going to be 4 here. Okay, I think that's all we need. We'll do more later.